Hello everyone, in this lecture we will discuss about the chemical equilibrium. Remember, first of all, remember that chemical equilibrium is a dynamic equilibrium. In the previous lecture we have discussed about the dynamic equilibrium. Now, in this lecture we will discuss about the chemical equilibrium. Chemical equilibrium. Suppose we have a reactant which is converted into B. With the passage of time, the A concentration will be decreased and the B concentration will increase. Now a time will reach in which the B concentration will become increased and a time will reach in which the A concentration will not change. So in that time B will convert it again into A and a dynamic equilibrium will be established. Suppose we have a reactant at the beginning, we have a reactant A which is converted into B. At start the concentration of A is very large and concentration of B is 0 or there is no concentration of B. Now when the concentration of A decreased, the concentration of A will decrease with the passage of time and the concentration of B will increase with the passage of time. Now a time will reach when the concentration of B will be become very high. So after certain time, when the concentration of B increased up to certain limit, then the B molecule or the B atom will react with each other and it will form the reactant again. So a dynamic equilibrium will be established, which is represented in the graph below. Suppose this is the time and this is the concentration of A and this is the concentration of B. So at first of all, at the beginning the concentration of A was very high and it was decreased with the passage of time. At the beginning the concentration of A was very high. This is Ca, the concentration of A. At the beginning the concentration of A was very high and then the concentration of A was decreased with the passage of time. And at that time concentration of A was become the equilibrium concentration of A. This is the equilibrium concentration of A, CaE. Similarly, at the start there was no B, so the concentration of B was 0 at the beginning. When the concentration of A decreased, then at that time the concentration of B was increased. It was increased with the passage of time. So after a certain time the concentration of A was decreased and the concentration of B was increased, and at that time the concentration of B is called the equilibrium concentration. This is the concentration of B. This graph shows the concentration of B. So at this time, at this time the concentration of B is called the equilibrium concentration, which is CBE. So this is the CBE, the equilibrium concentration of B. So at the start the concentration of A was very high and concentration of B was 0. When the reaction started, the concentration of A was decreased with the passage of time and the concentration of B was increasing with the passage of time. A time reached when the concentration of A a time was reached when equilibrium was achieved, and when the equilibrium was achieved, at that time 1 mole of A was converted into B, and 1 molecule of A was converted into B, and at that time 1 molecule of B was converted into A. So at the equilibrium the number of molecules which converted into B was equal to the number of molecules which was converted again into A in the reverse direction. So at equilibrium the rate of forward reaction is equal to the rate of reverse reaction. So this is about the chemical equilibrium. Thanks.